If we want to graph y equals 2 times 5 to the x minus 1, we want to start by graphing y equals 5 to the x. Hopefully we all recognize this as an exponential equation, and we're going to set up a table of values. I'm going to choose integers between -2 and 2 for my x coordinates, and I'm going to plug those x values into my equation y equals 5 to the x to calculate the y coordinates. When x equals -2, the y coordinate is going to be 5 to the -2, or 1 over 5 squared. This gives us a y coordinate of 1 over 25, or 0.04 as a decimal. When x equals -1, the y coordinate is 5 to the -1, or 1 over 5, which is 0.2. When x equals 0, y equals 5 to the 0, which is 1. When x equals 1, 5 to the 1 is 5. And when x equals 2, 5 squared gives us 25 for the y coordinate. We can now transfer these values onto my graph. So we now have a sketch of y equals 5 to the x. The y-intercept for that graph is 0, 1. The horizontal asymptote is y equals 0, or the x-axis. The domain is x is an element of the real numbers, and the range is y is an element of the real numbers, such that y is greater than 0. Let's see how those characteristics change with our new equation. So we're going to graph y equals 2 times 5 to the x minus 1 now. So we're going to change colors. Let's choose red for our new graph. Hopefully when we look at the equation, we're recognizing that nothing is happening to the x coordinates. They're remaining unchanged. The y coordinates, however, are changing. We're multiplying all of the y coordinates by 2 and subtracting 1. So on the graph, what that means is that we're vertically stretching the graph by a factor of 2, and we're shifting the entire graph 1 unit down. So there's a vertical shift and a vertical stretch. So when we calculate the new y coordinates, we need to take all of the original y coordinates that we just calculated. We need to multiply them by 2 and subtract 1. So at x equals -2, the new y value is going to be 2 times 1 over 25 minus 1. Getting a common denominator, I have 2 over 25 minus 25 over 25, and that gives me -23 over 25, or -0.92. When x equals -1, my new y coordinate is going to be calculated as 2 times 1 over 5 minus 1. So 2 times 1 over 5 is 2 over 5, and getting a common denominator, 1 is the same as 5 over 5. When I subtract those fractions, I get -3/5, or -0.6. When x equals 0, y remains at 1. If I take the original y value of 1, multiply it by 2, I get 2, subtract 1, gives me 1 back again. When x equals 0, my y coordinate is going to be 2 times 5 minus 1, which gives me 9. And when x equals 2, I take the original y coordinate of 25, multiply it by 2, and subtract 1, which gives me 49. Now 249 is not going to show up on my graph because 49 is too large a number, but the other points we can transfer onto the graph. So negative 2 is at negative 0.92, negative 1 is at negative 0.6, 0 is at 1, 1 is now up at 9, and 2 is at 49, which is off of our graph. So my new graph is going to look something like this. Our y-intercept is still at 0, 1. However, our horizontal asymptote has shifted down 1 to y equals negative 1. Our domain is still x as an element of the real numbers, but our range has changed. Y is an element of the real numbers such that y is greater than negative 1.